presentation.
Thank you, Julio. Okay, hi everybody. Today my presentation will deal with the design of a self-sustaining habitat for interstellar spaceships. And this project stems in the project Hyperion design competition that took place this year in 2025. And me and my team, we were the first prize winner of this project that have been organized by the Initiative for Interstellar Studies, an institute based in London, and that since 20 years explores the feasibility study for interstellar travel and have issued many papers and books on the topics. And my team was quite an interdisciplinary team, featuring architects, social scientists, not only astrophysicists or engineers, but also the social science and human science part, because our focus was the whole design of habitat, including systems of system for this generation spaceship. But we were provided with a broad array of general requirements, not only technical engineering requirement, but also social. We have to consider social structure, or the biological balance of the ecosystems, or the political architecture, and so on and so forth. So this was a task for a multidisciplinary team. What are generational spaceships? Basically, in the literature, there are different concepts proposed. There are two constraints, that is the trip duration and the total mass of the spaceship. Depending by the technologies used by the type of deep space propulsion system and so on, there are different solutions and scenarios, but generational spaceships currently are the only one kind of spaceship that are, with the current technologies, can be used for interstellar travel. The only constraint is the huge amount of mass that have used, since the population of a generational spaceship will be between 1,000 and 3,000 people. The main idea is just we have to reproduce a second biosphere as the one that is that the spaceship Earth, a self-sustaining ecosystem that not only include agriculture for food production, but also that will include all the biomes of the biospheres of the Earth's biosphere, in order to keep the ecosystem balanced and create also this heritage of the biosphere of Earth that will settle a new stellar system. These objectives are already been achieved by Biosphere 2, our research facility based in Arizona, during the 80s, that recreated a closed artificial self-sustaining ecosystem for a small crew of 10 people. But the real challenge is also about to recreate a technosphere. What do I mean? Recreate a complete circular life cycle for all the resources, material, equipment, machine that have to be brought on the spaceship, because it's just the spaceship will set out for a century-long voyage, and everything have to be packed, and nobody will provide any kind of refurbishment to the spaceship. So everything have to be completely closed and stocked in advance. This is the concept design of our spaceship, named Chrysalis. Basically, it's a very long cylinder of different modules that will be built in the Lagrange point L1 between Earth and Moon, just to exploit the resources and the equipments from the Earth, but also the resources from Moon, because it's rich in helium-free, the Moon, the regolith of the Moon, and can be used as a propellant for the nuclear fusion, direct nuclear fusion propulsion system. This is the configuration of our spaceships and the different mission phases. Basically, there is an acceleration module for a back module for the acceleration phase, as a front module for the deceleration phase. During all the voyage, the spaceship will be, the inhabitant will be hosted in the habitat module, that is the small green rectangle. So most of the bulk mass of the spaceship will be just propellant, and the total mass will be around 2 billion tons for a length of about 58 kilometers. If compared with the science fiction literature spaceships, this is Chrysalis chrysalis spaceship belong to the huge category spaceships. What I want to highlight here is that in science-based spaceships, not science fiction, the habitat will be a very small part of the entire spaceship because the bulk of the volume will be basically propellant for the acceleration for the long voyage. Okay, the habitat module is composed of 5 stages of different subshell, all nested inside and rotating at different RPM in order to provide 1 g of gravity for the habitat environment. And each shell hosts a precise habitat environment featuring agriculture and biomes, communal spaces for the population, the dwelling areas, the industrial facilities, zero gravity warehouse that will function as the depot for all the materials and resources, and a central access core that will put in link all the stages and will be also used for exit the habitat module during the in-orbit insertion in a new planetary system. This is just a preliminary located cargo for the different shells, just to give order of magnitude of the different things that have to be packed in advance. It's just if we have to recreate a complete, we have to stock and recreate everything that we need for the long voyage. So it's an interesting challenge to see how much tons of things we need, and we need to manage during all the voyage. The first shell is the agriculture shell that and the biome shell that include different biomes from Earth, like tropical forest, boreal forest, wetlands, and dry scrub, in order to preserve the heritage biodiversity of the biosphere. Each biomes will be confined and insulated from the other in order to provide specific light, temperature, and humidity. The big challenge is just to create a controlled ecological bioregenerative life support system, because we need to create oxygen, recycle carbon dioxide and all the other chemicals, regenerate the water, and also the wastes, the organic wastes have to be used for have to be recycled or used for the soils in order to keep the fertility of the soil and to generate food. So it is a well-balanced closed loop ecosystem that have to be included in order to keep a long-term balance of the biology inside the spaceships. There is the communal space shell that basically is an open space environment structured with columns where habitative columns where are included all the services like university, hospital, and so on. It's interesting to note how the perspective of the person inside these shells is quite not a plain horizon, but because we are inside a cylindrical structure, the environment will be quite curved, and also the perception will be a little bit weird. All the structures inside will be customizable and 3D printed through advanced printing materials. We have a dwelling area where all the houses of the for individuals will be hosted in order to have private spaces, and this will be divided in different sectors, and also the different sector will be, let's say, separated by parks and gardens in order to provide a relaxing and natural environment. And the houses and interiors will be built with advanced composite materials and multi-layer insulation for like secondary structures. A very important shell is, as I said before, is the industrial facility shell that will include all the machinery assembler, chemical plants, metal industry, engineering and physics labs, in order to create the components to building the things for maintenance, electric and robotics. This is the real challenge for spaceships that have to be everything that so-called technosphere that have to be thought in advance in order to be self-sustaining for a long time. And lastly, there is the warehouse that is like the big depot of the spaceship. It functions as a big reservoir for all the materials, resources, everything have to be stocked for be used during the voyage. And finally, there is the cosmodomes that it's quite an architectural feature that we inserted in the final part of the design. It's a big cupola that will host whole the chrysalis population and will function as let's say a structure that will give a sense of unity and of communality of all the individuals. And there is also a specific that the cupola will be composed also of transparent panels through which the people can look outside to the cosmos and give a sense of community and unity with the cosmos, because all the rest of the spaceship will be a closed ecosystem and it's not possible to look, let's say, outside. This is let's say, an analysis of the different domains regarding the long-term stabilities of these areas, because during 400 years trip, there will be many evolution in the different domains, such as social unity, ecosystem, the population number, cultural identity, agricultural yield, and so on. So we analyzed the weakness and the threats in order to see during the trip which are the part of the voyage that could be just where can arise some kind of threat to the stability of the entire system. We analyzed also the governance architecture. There will be basically an artificial intelligence agents that will interact with think tank investigation groups composed by the individuals of the population and also with the chrysalis population in a whole. Basically, will be a liquid social currency governance that will stimulate a collective consent decision making. This will be in order to provide to avoid degeneration in oligarchies or runaway of social fragmentation and class diversity, because this is a closed society, and so have to be fine-tuned in order to preserve stability. Also, there was the challenge of think about the psychological health, because basically many individuals in a generational spaceship will born, live, and die inside a spaceship and never will see the surface of a planet. So they will be confined in an isolated system for all the life. So we thought also about the idea to provide a cyberspace deep interface system in order to provide through neurosensorial and haptic peripheral devices a possibility for the individuals to break the natural physical barriers of the interstellar spaceships and joining a kind of virtual metaverse to interact with other inhabitants or to explore virtual world and to alleviate the idea to be in a confined space. So concluding, the interstellar studies are quite a broad area of research that not only include engineering, technical aspects, and physical exploration of the propulsion system, but it include a lot of inter and transdisciplinary research, because it's only holistically that all the different elements can be connected together in order to recreate the complexity that is the Earth's biosphere. And so in future, if maybe humanity will face with the challenge of human migration towards another solar system, it will be not only a fact of propulsion system, but also how to recreate a whole complex of a biosphere and social structure and all the circular economy, balancing of biological system inside this kind of small size Earth. Thanks for viewing, and if you have any question, I'm happy to address.